at 4.5 billion years old. This hot, glowing ball of hydrogen and helium has illuminated our solar system for eons. Sitting 150 million kilometers from Earth, life as we know would cease to exist without it. This is our Sun. Our solar system contains only one star, the Sun. It is the center of our solar system, and its gravity keeps it together. Everything in our solar system revolves around it, including planets, asteroids, comets, and small pieces of space debris. The Sun formed approximately 4.6 billion years ago in a massive spinning cloud of gas and dust known as the Solar Nebula. The nebula spun faster and flattened into a disk as it collapsed under gravity. Most of the nebula's material was drawn towards the center to form our Sun, which accounts for 99.8% of the mass of our solar system. The planets and other objects that now orbit the Sun were formed from much of the remaining material. The Sun is approximately 100 times larger than Earth and 10 times larger than Jupiter, the largest planet. At its core, the temperature is approximately 15 million degrees Celsius, which is hot enough to sustain nuclear fusion. This generates outward pressure which supports the star's massive mass and prevents it from collapsing. Because of the way the Sun rotates, measuring a day on it is difficult. It does not spin as one solid ball. This is due to the Sun's surface not being solid like the Earth. Instead, the Sun is made of plasma, a super hot, electrically charged gas. On different parts of the Sun, this plasma rotates at different speeds. At its equator, the Sun completes one rotation in 25 Earth days. At its poles, the Sun rotates once on its axes every 36 Earth days. The Sun is a star, and when a star explodes, it's known as a supernova. These explosions are incredibly bright and powerful. They emit a large amount of dust into space, which is used to create more stars and planets. These explosions provide the raw materials for our solar system. The entire solar system would be destroyed if the Sun suddenly exploded like this. A supernova explodes like a balloon. However, when our Sun dies, it will do so gradually, more like when you slowly let the air out of a balloon. This death will occur when the Sun runs out of fuel in about 5 billion years' time. It will grow larger and slightly colder when it begins to die, becoming a red giant. It will grow so large that it will consume Mercury, Venus, and even Earth. When the Sun becomes a red giant, it becomes large and puffy and begins to blow its outer layers out of the solar system. Over time, it will shrink. The core of a dead star is called a white dwarf. They are massive, weighing nearly as much as the Sun, despite only being the size of Earth. Most of the solar system still exists when the Sun becomes a white dwarf. Mercury, Venus, and Earth would have gone, but Mars, Jupiter, Saturn, Uranus, and Neptune will continue to orbit the Sun. So will the asteroid belt, Kuiper belt, and dwarf planets like Pluto. Because a white dwarf is small, it produces less light. It lacks fuel to provide its energy, so it becomes colder and colder over time, eventually becoming very dark. The Sun's light is what keeps our planet warm. Without it, planets in our solar system will become extremely cold. This will make it more difficult for life to survive in the solar system. However, in the future, humans may be able to build spaceships that will allow us to leave Earth. Humans may also devise a way to move Earth itself. Hi, my name is Mr. Science, aka Salim. If you're new to the channel, please remember to like and subscribe, and for more teaching resources, you can visit my website at www.mrscience.co.uk.